Hi, this is Tim. Today we're going to answer a viewer's question. This question comes from Zachary, who is one of our Patreon supporters, and I'll talk more about them at the end of the video. But Zachary asked, how would you control an analog input with digital inputs? I want to set my drive to one speed with one input, and then to a different input, a second speed. We can do that with some really simple code. But I think a lot of us get stumped on how to take digital inputs, which are ones and zeros, and make them do something analog. First, let's clarify one important thing. Zachary said he needed two speeds and he was using two inputs. Well, with two inputs, we can actually get four speeds. And that may be worth a video. Have you ever ran into the saying in the automation world that there's 10 types of people in the world, those who understand binary and those who don't? Well, if you have heard of it, go ahead and hit that like button. And if you haven't, ask the question in the comments and maybe I'll do a video on it. But if we take a combination of our two inputs, and I'm just going to name them DI1 and DI2, then first with both of them off, we can have speed 1. With input 1 on and input 2 off, we can have speed 2. Then we can do the opposite. We can have input number 1 off and input number 2 on. That's going to be speed 3. And then finally, we can have both input 1 and 2 on, and that'll give us a fourth speed. So I'm going to go ahead and set it up that way. For this video, we are using one of our PLC trainers. This is the Micro820 PLC with the HMI option. And I just have a basic voltmeter connected to the voltage output on the Micro820, which is terminal number V0-0. That's where I have the red wire. And then I have the black wire going to the 24 volt common or the minus terminal. I'm just going to arbitrarily assign values to our four speeds. I'm going to make speed 1 0 speed. Speed 2, I'm going to make 25%, speed 3 50%, and speed 4 100%. To start with, let's open up a new copy of Connected Components Workbench. And I am just going to call this digital to analog speed, and we're going to select a controller, Micro820, and we're using the 2080 LC20 20QBB. Select it, and I'm going to add it to my project. And then most importantly, as we're creating our programs, we need to set that Ethernet address. So let's go to Ethernet, scroll down here, and let's configure our IP address. And for this setup that I have right now, it's 192.168.1.14. And I have a subnet of 255.255.255.0. Now, if you're using one of our standard trainers, we've been typically using 192.168.110. Now let's right-click Programs, Add, and we're going to add a ladder diagram. And before we even get into programming, let's go to our global variables. First, we have our digital inputs, and you can tell that by it's an IO, EM for the embedded module, DO for digital output, and then we have a number. Then after that, we have our inputs. Then we have AI, which is our analog input, and then finally, we do have this analog output. Now, we have a video that actually goes through the analog on this and the scaling, but let's do a quick refresher on it. Let's download this program just as we have it. If you need any help downloading your program, configuring drivers or anything like that, we have lessons on all of it. And then once you're done, make sure you put your controller back into run mode, and let's open up those global variables. And now let's highlight the IO, EM, AO00, which is that analog output. And I'm going to put my meter on 20 volt DC. So right now we have 0 volt. Now let's just throw a number in arbitrarily. Let's just throw in 100. All right, and we got a little action here. Looks like we got about 1/4 volt. And if we go ahead, let's go ahead and put 1,000 in. And yeah, we're going to get a little more action. Now we have 2.5 volts. And so roughly 1,000 units is going to be 2.5 volts. Now the full scale is 4008. So go ahead and enter 4008. And now we have 10 volt. So 4008 is going to be this 100% speed. Now we can do it a sloppy way or we can do it a cleaner way. Let's do a quick crash course through the sloppy way and then I'll show you how I would do it and I hope you would do it. It's okay, I just said 4 is 4008. Well, okay, if we want 50% of that, that's going to be 4008 times 0.5 or 4008 divided by 2. So speed 3 is going to be 2004. Then our 25% speed is going to be half of that 50% speed. So in that case, it's going to be 2004 divided by 2, which is going to be 1002. And then finally, we have our 0% speed, which will be 0. So I could take these numbers and just plug them in. But the issue is when the next guy comes around, or even it's you in a few years, are you going to really remember what the world these numbers were? Probably not. So what I'm going to do is I'm going to actually scale this analog from a min of 0 and a max of 4008 to a min of 0 and a max of 100 for 100%. So let's go offline and then let's open up our program and we're going to bring down an instruction block. And then let's start typing SCL and go ahead and bring that in. And this is going to be our scaler. And for our input, we're going to create a variable. And let's just call this our output in percent. And that's going to be a real number. We'll select it. And if yours is like mine, it's a little cut off. You can't really tell it. These first two say in raw, and you can't see what else it is. But if you mouse over it, it tells you what they are. So the first one is in raw max. So our in raw max is of these scaled units that I'm going to be using, which is 0 to 100%. What's the largest number? And it is 100. So we're going to enter 100 here. Oh, no, we're not. You notice when I entered that, we got this little triangle here. And that's because this came in as a lint. And if you mouse over this, this is calling for a real. So to fix that, it's really simple. All you got to do is make this instead of 100, it needs to be 100.0. And then our min is going to be 0. So 0.0. And now, what output do we want? Mainly going to our analog. What is it scaling? Well, it's going to be 0 to 4008. So I am going to enter 4008.0, and I'm going to enter 0.0. Then we need to assign it an output, which is going to be our analog output. Now, double-click on this and go to your I/O tab. And you're going to notice it's not there. And the issue is we have the wrong data type. So let's go to our global variable here and just have a look. And right there, this data type is Word. If we go back to our program and mouse over it, then our out is real. We're going to need to create a variable for that. So double click here and just start typing. Let's call this output in raw scale. And that's going to be a real. Okay, so that gets it to there. But we still don't actually have it in our analog value. And this is where the really cool any instruction comes in. And this is just, I should do a whole video on just amazing headaches that the any instruction can solve. So right now, our value is real. But if we go to our global variable, we need to have it as a word. If we go over here and we double click on that instruction, we're going to start typing any, and we're going to see right there, any to word. So now we'll take that output in raw scale and put it on the input of that any to word. And then we're going to select our global variable. And this time when we go to our I/O tab, that analog value is going to be there. Let's download this and make sure we understand how the scaling is working. Okay, and the most immediate thing I notice is my voltmeter went immediately to 0. And right now, our output percent that we just created is also at 0. First, let's go for 100%. Let's make sure that we get 10 volts. So if we double click on our output percent, it's going to bring you to that tag. And we're going to put in 100. And there you go. We have 10 volt. And if we put in 50, we should have 5 volt. So our scaling is there now. And later on, when we look at it, we'll be able to understand 0 to 100%. Well, while we're at it though, maybe that doesn't make sense to you. Should it be 0 to 10 volt instead of 0 to 100%? Because we can do that real quick. Let's go ahead and do that. Let's close this out and go back offline. And right now, our scaling here is 0 to 100. Let's just make that 0 to 10. Now, one thing we didn't talk about also is this limiting here, and we probably should just briefly hit it. Let's highlight that SCL and press F1, and that's going to bring up our help on that instruction. And if we scroll down, then we're going to see limiting. And if it's true, the output will be limited between the EU min and the EU max. So let's go ahead and leave that alone so we can understand exactly what it does. Okay, so now if I enter into my output percent, which actually I should have changed it, it's now output volts, but let's put in 10. And we get 10 volt. And if we enter 5, we're going to get 5 volt. While we're at it though, let's go ahead and cover this limiting thing. Is let's say we didn't have limits on our scaling coming in and it ends up at 20. Well, we did get a squeeze more out of our voltmeter because this is actually 0 to 10.5 on its analog. But notice this value that's actually in our analog output now. It's 8,016. So let's enable this limiting here. And all we got to do is go here and type true. And now, even though we still have this 20 here, it's going to be 4,008 at the max. So that's what that limiting is going to do for you. Now, I don't like that this says output in percent. Next time we're changing something, I will try to remember to do that because it's a little deceptive now with it saying output in percent, but actually now it's output in voltage. But mainly, either whether you're doing output in percent or output in voltage, I think that's better than just plugging in these crazy numbers into it. Okay, so that was a long segue to get to actually answering Zachary's question. Is all right, now we need to add something, and let's see, what do we have wired in here? Okay, we got input 4 and 5. So we're going to use input 4 and input 5, and we're going to make these 4 speeds happen. So let's go ahead and go offline. And it was bugging me about the output in percent, so I'm going to go over here and change it. That will now be output in volts. There we go. And when I change it right here, if we go back to our program, you see it changes it right here. Everything's done for you, and that's much clearer now. But let's go ahead and add a rung right above it and start working through our cheat sheet. So first we have, well, I called them N1 and N2, but 4 and 5 are already wired to my trainer. So first we have input 4 is a 0 and input 5 is a 0. So yeah, go look for a 0 on both of those. So I'm going to get a reverse contact, examine if open, or as I like to call it, I go look for a 0. And we're going to go to our I/O tab, and we are going to look at input number 4. And then, just to make life easy, we're going to copy and paste that and change the second one to a 5. And then we're going to get an instruction block. And we are going to use an MOV, which is a move command. Now there's a couple ways I could do this, and actually I'll do a mixture of them. First, I can just type the value in here. So I'm going to move a 0, and I'm going to move it into this output in volts. So output in volts. Now let's just highlight Control C and Control V it 3 times. So we'll have 4 identical looking rungs. And then what we're going to need to do is change them to match our truth table. So our second rung will be go look for a 1, go look for a 0. So I'm going to bring down, go look for a 1. And you can either navigate to it or you could just come over here and highlight the one we did have, Control C, and go right here, Control V, and then delete that one. And in this case, let's say I'm not sure what drive speed 2 should be. Well, in that case, let's just create a variable that we could change later. I'm just going to type drive speed 2, and that is going to be a real and then in the third rung's case, if input number 5 was a 1, so we'll drag that down, and again we could just copy and paste, or we can navigate over here to it, and then we'll delete that one out. All right, and again, maybe I'm not sure about this speed. Let's create a variable for it. This will be drive speed 3, and again, it will be a real. And then finally, we had when they're both a 1. So we'll bring down a few, go look for 1s. And again, we'll go over, and this one will be input number 4. This one will be input number 5. This one, I am sure about. I want it to be 100%. So 100.0. Now if we compare or go look for 1s and go look for 0s down here, they will match up exactly with what we have here. So we've taken those 2 inputs and we have 4 drive speeds now. Now we didn't actually assign anything to drive speed 2 or 3 yet. Well, we could do that before we even go online with it, as we have this project value. We haven't talked about it a lot, but when you're downloading a program, you notice it asks you, do you want to download with project values? And you also have an initial value. Well, if we just go here and for our project value, what did I say? 25. So drive speed number 2, we're going to put 25. And drive speed number 3 was 50. All right, let's go ahead and download this and see what we have. Oops, and okay. If you did yours just like mine, I missed on that first one. I put 0. And again, that makes it a length. We need to make it 0.0 so the Connected Components Workbench will recognize it as a real number. Now I'll download that again. And also, as we're downloading, we might as well look at that. So I'm downloading with project values, and well, immediately it does go to 0 because we went into program mode. So anytime that is in program mode, it is setting this analog value to 0. Okay, and you should feel pretty confident that rung 5 works now. We tested it before we did all this. So let's just get up here where we can see rungs 1 through 4 at the same time. And right now, we are showing a value of 0. So now I'm going to press button 1. Uh-oh. Oh, well, okay. And yeah, if you recall, we changed values from percent to voltage, but I kept these values that we were pushing into them as percent. So the moment I press the button, it's showing 10 volt. And okay, we do need to see rung number 5, because if I go down here, then we're giving it 25 volts. And again, that limit function we added earlier is important here because it's going to hold it at 4008. So we do have that limit in there. I can fix this without even going offline. Hey, there's always a learning opportunity, right? Is if I give it 100, it's going to only give out 10 volts. And my first one is 0, so it is also correct. So if I just go here to my drive speed, I can change drive speed number 2 to 2.5, and I can change drive speed number 3 to 5. And now, when I press button 1, I'm going to get 2.5 volt. I let off, it's going to go back to 0. I press button 2, I'm going to get 5 volt. I let off, it's going to go back to 0. And we finally have the combination of if we press both buttons, we're going to get 10 volt. Now we do need to fix this. As right now, if we hold these two buttons and we go down, it's showing 100 volts there, and that needs to be 10. So I'm going to make one more offline change just so we can make sure we do it right. And even if your program works and you see something like that, don't run off saying, yay, my program works. Go ahead and fix it. Just that way later on, we're not like, why do we have 100 there? Shouldn't it be like 10? I mean, don't leave any room for guessing. Oh, I just made a mistake there. Did anybody catch that? So I just talked about how we hadn't talked about much about downloading with project values compared to not downloading with project values, is I just hit that download with project values. And what that does is it takes whatever we had entered in our offline program and puts it into the PLC. So those changes that I made to these two variables just got overwritten. And we probably should do a video talking about that one day. But yeah, so let's go offline one more time because yeah, especially since I was stressing you need to fix it correctly, completely, is really the project value here, if that's what we wanted, now needs to be 2.5. And the second one needs to be 5.0. All right, and then we download that and everything should be correct. Now you may not want to use that project value field here. I was just kind of throwing that in as an example while we were doing this. Okay, so now we press button 1, we're showing 2.5, let off, goes back to 0. We press button 2, we're going to 5 volt, let off, back to 0. And finally we press both of them and we have 10 volt. So I hope that helps you out, Zachary. You only asked for 2 speeds, and really, in that case, you probably could do it with 1 unless you happen to need that it's not running. And in that case, you actually do need the exact combination I did, and you just have a turbo speed kind of hidden in the background if you ever need it. But thank you, Zachary, for asking this question. Also, super big praise and thanks to our Patreon supporters that help us make videos that, one, we don't have hardware for. And also, if you didn't know it, obviously, they do get first dibs on what we make videos on. So in a second, you're going to see an end note come across that says, hi, this is Tim and this is Amber. Thanks for supporting us. Well, we point a lot of different directions, and please click one of them, whether it be clicking the next video or whether it be hopefully clicking that support us on Patreon. It's much appreciated. Till next time. Hi, this is Tim.
And this is Amber of TW Controls. We run the automation store. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like this video.
Please like our video and subscribe to our channel.
And if our videos have helped you make some money and you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya!